Okay guys, as you can probably tell, I'm feeling a little under the weather, but we got to move on with our math class. So I thought I'd make you this video for your notes today so we can move on and start chapter 9. First, if we look at the calendar on delamath.com, today is Wednesday, so we are starting 9.1 today. And then as we move on, it looks like we don't have any assessments going on this week, but next week on Monday, hopefully I'll be back by then, and we will have a homework checkpoint on Monday. It looks like next Friday we will have our first quiz. So keep an eye on that calendar because we are going to stick to this. First assessment is next Monday and then a quiz next Friday. All right, let's go ahead and start our notes. So please take out your notebooks and label 9.1, Introduction to Functions. And then you see here, we do have our objective. We are going to analyze and graph relations, and we're going to find functional values. Okay, I'm going to move to the next slide. If you're all not ready, then you better stop the video here. Okay, let's start with some definitions. First off, I think you guys already know what an ordered pair is, but it's important to note that the x and the y value of the ordered pair have different names. Did you know that the x value, or the first value of an ordered pair, is called the domain? That's always the first coordinate, and the x value, or the front number, is also known as the independent variable. That makes the second coordinate also known as the range, and is the dependent variable. So depending on what happens to x, y will be affected. X changes and y is affected. X is the one that's independent and you can change it, and then depending on what happens to x, the y value will change. So if I gave you a list of coordinates or ordered pairs, this whole list is what's called a relation. This is a relation of 3 different ordered pairs. And I could ask you to tell me the domain and the range of this relation. In fact, that's what I'm going to ask you to do right now. We're going to separate this out into the domain and the range. I like to call these little circle or oval things. They kind of look like Easter eggs for me. I don't know. I always teach this in the springtime, so Easter eggs are on my mind. Anyways, to map this relation, we're going to draw a little oval for all of our domain values and a little oval for all of our ranges. So if I wanted to fill in the domain, well, I know that the domain is just all of the x's, so I would just literally steal all of the x's. I've got 12, 15, and 8. And I want to make sure that I list those without doubling up any of the values. So if there was 2 12s written as a domain, I would only list it once. Then to fill in the range, it's very easy. It's all of the y values, so that's 28, 30, and 20. It doesn't have to be in any particular order, but here is our relation mapped as a function right here. Let's define that word function right now. A function, this is an important definition. This is what all of chapter 9 is about. A function is a special type of relation where every member of the domain is paired with exactly one member of the range. Keep this bit in mind because in a couple minutes here I'm going to ask you if something is a function or not, and I bet you I'll trick you. Remember, every piece of the domain is paired with only one member of the range. So domain goes to only one range member. Make sure you have this definition in your notes. What we're going to do is we're going to try to decide if the following 3 sets of relations are functions or not. So you can label this as example 1 in your notes. And you need to get all 3 of these down. So the way we're going to do this is we're going to map it out just like we did in the first example. Let's name the domain in the first relation. So all of my x's, that's -3, 0, and 2. And then the range comes from all the y's, 1, 2, and 4. When I look down at my domain, I need to make sure I haven't repeated any numbers. And then same thing with my range, I haven't repeated any numbers. Next, I'm going to draw an arrow that represents how, like if I plug in this number for x, this is the number I get for y. So we're going to draw an arrow that represents -3 gives us 1. So when I plug in -3, I get a 1. When I plug in 0, I get 2. So 0 goes to 2. And when I plug in 2 for x, I get 4 for y. So does every member in the domain pair with exactly one member of the range? Yes, this is a function. So that seems pretty simple. Let's mix it up a bit. All right, the next set here, let's go ahead and name our domains, -1, 1, and 4. And then our range is 5, 3, and 5. Remember, we don't list the number twice, so I'm just going to write 5 and 3. Again, I know my range is a 5, a 3, and a 5, but I don't want to list more than one number in either one of these Easter eggs. Now let's go ahead and draw our arrows. -1 pairs with 5. 1 pairs with 3. And 4 pairs with 5. Now my question for you is this relation a function? Go ahead and reread the definition of function to yourself and decide if this guy is a function or not. Guess what? This is a function. The definition says that every piece of the domain pairs with exactly one member of the range. So if we look at the domain by itself, -1, he only goes to one member of the range. 1 goes to only one member of the range. 4 goes to only one member of the range. So because all of these guys each go to one different select piece, then yes, this is a function. A lot of people will get confused here and they'll say this is not a function because they see a problem with this 5. They say, hey, there are 2 different guys coming to this 5 over here. That doesn't matter. I'm only focused on the domain. As long as all of the domain goes to separate places, so the -1, the 1, and the 4, all of those arrows are going to different places, then we know that it is a function. Let's take one more example and I'll give you a hint. This one down here is not a function and you can maybe clarify any misconceptions. Again, we're going to start with the same thing. Let's go ahead and name our domain. I've got 5, -3, and 1. Notice I did not label the -3 twice because you only name each piece of the domain once. Same with the range. I've got 6, 0, 1, and 6. Again, I'm only going to put 1, 6 in there. So 6, 0, and 1. Let's go ahead and draw our arrows. 5 goes to 6. -3 goes to 0. 1 goes to 1. But -3 also goes to 6. This is the problem. This is not a function because of this issue right here. -3 is a member of the domain and it is not paired with only one member of the range. See how it is going to 2 separate versions of the range there? So it's important to note that it is okay to have a member of the range, so like this 5, have 2 different arrows coming to it. However, it is not a function if a member of the domain has 2 different arrows coming from it. So again, we're only focusing on the domain here. The domain is the only restriction. The domain is only paired with one member of the range. All right, this is another example, and it's instead of giving you just a list of a relation, I gave you a graph of it. We can still do the same thing here and go ahead and make our Easter eggs. So if I have a domain oval and a range oval, I could label all of these points. So I do have a point here, -4, 3, that I could put in, and I'm going to put -4 maps to 3. I also know that -1 maps to -2, 0 maps to -4. Next up is 2 maps to 3, be careful. 2 maps to 3, which is already on there, and then 3 maps to -3. So is this a function? Again, if I only look at the domain, all of my numbers here have just one arrow coming from it. So I would say, yes, this is a function. Your next vocabulary words to define are discrete and continuous. Relations, or a bunch of ordered pairs, remember that's what a relation is, can be either discrete or continuous. They won't be both. A discrete relation is a set of individual points, where a continuous relation is a set of infinite points, usually representing a curve or a line. The easiest way that I decide between a discrete or a continuous function is if I can draw the picture without picking up my pencil. So if I wanted to draw this picture, I would have to draw a dot and then pick up my pencil and draw another dot and pick up my pencil and draw another dot. Because I had to pick up my pencil, I know it is discrete. I could draw this continuous line without picking up my pencil. Even though I know it continues on forever, this is a continuous function because it can be drawn without picking up your pencil. Similar functions that are discrete are functions that are step functions. You might have seen something like this in Algebra 1. I could not draw this picture without picking up my pencil. A parabola, that's a continuous function. It goes on and on and on forever, but I could draw that U shape without ever picking up my pencil. Last, this might be something you're familiar with. To decide if a picture is a function or not, you can use the vertical line test. The vertical line test is used when you draw a vertical line through a graph, and if it only intersects the graph at one point, then that graph is a function. Make sure you get this in your notes, please. So, if I was looking at this picture, for example, this looks like some kind of weird looking, it's not a parabola, it's like a double parabola. This is probably a cubic function. Here's a vertical line going up and down. No matter where I draw that vertical line, I will only intersect the graph at one point at a time. Right here, for example, if I drew that line over here, I'd only intersect right there. Because I only intersect at one point at a time, this is a function. This semicircle, however, intersects the graph at 2 points, so this is not a function. You can see that the vertical line test is doing the same thing as the Easter eggs. Because if you think about it, domain and range is really comparing our x's to our y's. So for every x value you have, it is only allowed to go to one y value. It is not allowed to go to 2. So if I was here, for example, at x equals 2, and my y value could either be -2 or +2, my domain and range bubbles would look something like this. For this x value of 2, I'm either going up to +2 or down to -2, so my Easter eggs will be looking like this, which means it's not a function. The vertical line test is a quick visual to do this in the background. Last but not least, we're going to add a little bit of algebra to this with function notation. This is what you might be familiar with. This is read as f of x is equal to 2x plus 1. The f here is the name of the function. I could also name it h or g. So function f, function h, function g. F of x, this notation is the exact same thing as saying y. So that means that this sentence is the same as this sentence. F of x, again, the f part is the name of the function, and the x is the variable within that function. f of x is read f of x. So if it was g of x, we'd say g of x. Kids try to read this to me as f parenthesis x. Come on now, use the actual words here, f of x. It's important to note here, and this is just a side note because I run into this problem every year, the f here is just the name of the function. You are never going to be solving for f. F is not a variable to solve for. You are using x as your variable. So these letters out front, these are not variables. They're not something to be solved for. So don't be solving for f. It'll make sense here in a second. All right, let's go ahead and label this one as example number 2. Given that we have this function, f, and f is the function that takes some variable called x. It looks like he cubes it, and then he adds 2 times it, and then minuses 3. Our job is to find what happens when we plug in negative 4 into f. So that means we're going to rewrite this equation, and for every x that we see, we are going to replace it with a negative 4. So that means I'm going to write f of negative 4 equals, and then for every x we see, we're going to replace it with, I would suggest parentheses, negative 4. So this guy is negative 4 to the 3rd power plus 2 times, instead of x, I'm writing negative 4 in parentheses, and then minus 3. Our job on the left side of the equal sign is done. We do not need to do any math here. A lot of students will try to solve this equation for f, so they will divide by negative 4, and that is what I was referring to on the previous slide. You do not need to solve for f, so we do not need to do anything on the left side of this equation. We just simply need to simplify what this number is. So it would be very easy to plug this into a calculator. If you choose to do that, that's totally fine, but I would like you to show your work by at least writing out this portion of the equation. So if I was to do this in my brain, however, I know that negative 4 to the 3rd power is negative 4 times negative 4 times negative 4. So that's negative 64. And then I would do negative 4 times 2, which is negative 8. And then I have to minus 3. These would all combine to give me negative 75. So then my answer to this equation would be f of negative 4 equals negative 75. And yes, it is important that you include this part in your answer, because this is telling your reader, as your mathematician audience, your reader says that, hey, I plugged in negative 4 into the equation f, and I got negative 75. Okay, so this would be your final answer to example 2. Example 3, I kind of ran out of room there. Let's just move it down a bit. Says find the function if we plugged in 2y. So remember, the function is f of x equals x to the 3rd plus 2x minus 3. And now we're finding what will happen if we plug in 2y. So for every x we see, we're going to replace it with 2y. So the first one, we've got a cube. The second one, we're going to times it by 2, and then we're going to subtract 3. Remember, the stuff on the left side of the equal sign is not going to change. We're just going to mess with the other side. So let's go ahead and simplify this. I've got 2 to the 3rd, which is 2 times 2 times 2, so that's 8. And then y to the 3rd, so y to the 3rd, plus 2 times 2 is 4y, and then minus 3. Do I have any like terms that I can combine? I have a y to the 3rd, a y, and a negative 3, so nope, that would be my final answer. I can't simplify any further. Again, this notation says, hey, I took the function f, I plugged in 2y, and this is what I got. All right, that's the end of our slides, our notes. Please pause this video and pass out the homework so we can look over it together as a class. Okay, the very first part of your homework assignment asks you to define what domain and range are. Domain is all of the x values of an ordered pair or of a relation. all of the x values in a relation. The range is all of the y values in a relation. That should be pretty easy. Domain is x, range is y. All right, next set. For number 1 and 2, find the domain and range of each relation, then draw a mapping and a graph for each. So it looks like we need to take these numbers, list out the domain. Remember, you don't have to list them in any order, but there should be no repeats. So the domain for this first one I would say is -3, -1, 0, 2. Notice I did not list 2 twice. The range is -4, -3, -1, 3, and 5. Then I need you to take those guys and put them into your ovals. Here's all your domain. Again, it should just be the same as this list. Here's all your range, the same as this list. Finally, I would like you to draw arrows mapping, just like we did in the notes, and draw a graph of these. Here's your x comma y point. So if my first point is -3, -4, I need to go left 3 and down 4 and put a point, something like that. And then you can do the next one, and then you can go ahead and move on to number 2. Later on, it will ask you if number 1 is a function or not, down here. So you can say yes or no, and you can say why. Okay? Before you do that, you need to define what a function is, and that's straight off your notes. You should have this definition. Let's go ahead and turn to the back page. You're going to continue this process and decide if things are functions or not on the back side. So here's a list. Can you decide if this is a function or not? Decide if there's an issue with the domain, one member in the domain going to 2 different members in the range. Remember, that's really what you're looking for. Is there a domain member going to more than one member in the range? With the pictures here, you can just go ahead and use the vertical line test to tell if that works or not. Finally, I would like you to plug in the values listed for 9 through 17. For 9 through 14, you're going to solve each of these ones as if x was 6. So you're going to put g of 6 equals 2/3 times 6 minus 1. And then for down here, you're plugging in, looks like 15, you're going to plug in -8 for x. So 4 times -8 minus 2. That's all I want to know. What is 4 times -8 minus 2? Okay, here you're plugging in -2. Plug in -2, tell me what you get. All right, it seems pretty straightforward. Remember, if you get stuck on any of these, there is an answer key and a homework video on my website, so you can get more help as needed. If there is any class time left, please use that time to get started on your homework.